Lecture 7 of Basic Electronics is about DEMOSFET.
Hello, welcome back to our channel ClassFly community. So today we will be dealing with the third part of the MOSFET, or you can say today we will be dealing with the types of the MOSFET. We all know that types of MOSFET are two types. That means one is a depletion, another is a enhancement. And when does depletion happen? When negative gate bias voltage, it acts as a depletion MOSFET. Okay. Whereas when it is positive gate bias voltage, it acts as an enhancement. So here we will be dealing with the construction of the DMOSFET and the operation of the DMOSFET. The basic difference between DMOSFET and enhancement MOSFET or eMOSFET you can say, we will see with the diagram. So before that I would tell you that the construction of this DMOSFET is being doing with the help of the N-channel depletion. So it says that it consists of a highly doped P-type substrate into two blocks of heavily doped N-type material are diffused, forming the source and the drain. So let's see the picture and you can perfectly picturize. So here is a P-type substrate and there are the two wells of N-type which are highly doped and which are connected. One N-type is connected to the source and this is a metallic layer which is given so that there is the connection which can be made with the source and with the drain. Drain also have the same metallic layer and it is also connected to the another N-type. Okay. So an N-type is formed by diffusion between the source and the drain. So it will be diffused between the source and the drain and this N-channel gets formed. So the type of impurity for the channel is same as for the source and the drain. That means the impurity which will be happening will be similar for both of them. That means for the source as well as for the drain. The main thing about here is that there is a P-type substrate and there will be a SiO2, that means silicon dioxide, which will be working as an insulator here. Okay, so it will be working as an insulator, or you can, in terms of capacity, you can say dielectric, and is drawn over the entire surface. You can perfectly see it is here for the entire surface, right? And to make contact with the N-type blocks. So they are contacted with the N-type block. So metal is deposited through the holes to provide drain and the source terminal. So metal will be deposited and through the holes. There will be holes from where the drain and the source terminal will get provided, and as it is told that on the surface area between the drain and a source a metallic plate is deposited. So this is the metallic plate which is being deposited. Similar for the gate also there is a metallic plate. So that states that this layer constitutes the gate also. So basically there are three terminals here. That one is source, another is gate, another is drain. Perfect. Now see that SiO2 layer, this will result in a very high input impedance. That it will cause a very high input impedance for this area. Now the basic thing is that in this N-channel DMOSFET, the DMOSFET, the structure is what? There is an N-channel. There is a channel between this N-type and this N-type. This is the basic difference between a DMOSFET and an enhancement MOSFET. Enhancement MOSFET will not have this diffuse channel. Okay, and similarly we can make a P-channel DMOSFET constituting like an N-channel DMOSFET starting with an N-type substrate. Instead of P-type substrate we will be having an N-type substrate and diffusing a P-type drain here as well as a P-type source, and there will be a P-type doped channel again in place of this N-channel. So this is the basic construction of a DMOSFET. I have written in points and I have made you understand through the points very well, I hope. So see, whenever you will write like this the construction, so that everyone can understand easily. Okay, so this was the N-channel DMOSFET structure. So now let's move on and see what happens to its operation. Okay, now let's move. So here we have the operation. Here also I have done in points. So it says that DMOSFET can be operated with either a positive or a negative gate. See, this is the basic thing why the MOSFET is being operated with either a positive or a negative gate. So when gate is positive with respect to the source, it operates in the enhancement, or you can say E mode, and when the gate will be negative with respect to our source, illustrated in the figure. So let's see our figure. So this is a figure. So you can see now here it is positive and negative. That means it is stating that here what happens, here it is acting as in the depletion mode. Okay. But when it is positive here and negative here, at that point it will be working as the E mode or the enhancement mode. So what happens, first of all we give the source to the drain as and the source, and the drain is positive and the negative, and we don't give the, first of all we don't give the voltage or the supply to the source and the gate. At that time also ID current will be moving, that is drain current will be moving. But as we give our source to this gate, and when in the gate is a negative, what happens, this negative will repel here this negative, and this will cause that it will make here a region which is full of positive. Okay. So see, it says that when the drain is made positive, that means drain is positive with respect to your source, and a drain current will flow. So I already told that the drain current will flow even with zero gate potential. That means when the gate will not be given any supply, and the MOSFET is said to be operating in the E mode. That means at that point of time it will operate in the E mode, and in this mode of operation, gate attracts the negative charge carriers from the P substrate to the N channel, and thus reduces the channel resistance and increase the drain current. This means that at this point, as it is a zero gate potential and it will be operating in the E mode, so it will be attracting this negative portion. That means it will attract the negative charges, so and it will create this positive negative channels like this one. Okay. So it states in this mode the operation it attracts the negative charge. So it will attract this negative charge and carries from the P substrate to this N channel, and it will carry this from this P substrate and it will create here in the N channel, which will cause this channel in reduction in the resistance, but it will increase the drain current. So that means the more the positive gate will be, that means the more positive the gate will be made, the more will be the current flows. That means the more the drain current will flow. But on the other hand, when the gate is made negative, that means in DEMOSFET we can operate in both positive as well as negative. So till this portion it was positive. Okay. So now when this gate is made negative, what happens? This will repel this negative charge. So negative charge with respect to the substrate, the gate repels some of the negative charge carrier and carries out of the N channel. This creates a depletion region in the N channel. So this will create here a depletion region in this N channel as it is being shown. Okay. So that means all these minus charge will be repelled by this gate when it will become negative. And what happens? It creates a depletion region here. Okay. Now what happens? This increase the channel resistance and it will decrease the drain current. That means as we increase the negativity of this gate, the drain current will also be reduced. That means this gate supply depends on our drain current. So it states at the last line, the more negative the gate, the less the drain current will be. And in this mode of operation, the device is referred to as depletion mode MOSFET. That means here what happens? It will be depletion mode MOSFET, and here too much negative gate voltage can pinch off the channel. So it will now pinch off this channel. This operation is quietly similar to our JFET. Okay. So this was the basic operation of the DEMOSFET. So I hope you all understood. So we will next on move on to the enhancement MOSFET, how it works and how it is constructed. So till then be happy and have a very great day.
Now is the quote time. Anger, resentment, and jealousy doesn't change the heart of others, it only changes yours. Thank you for watching the lecture of today.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.